Okay, this video is Functions Intro 1.1 Part 2 for pre-calculus. So number 2, determine if each table represents a function. If it does, find f of 1 and f of 6 and solve f of x equals 1 and f of x equals 6. So one thing I want you to know is for this particular problem and one similar to this, don't extrapolate. Okay. The table. So I'll try to make sure I add that in the directions. So for this particular one, just stick to the data set given in the table. Sometimes you do extrapolate for particular problems, but we're not doing that here. So for the first one, we have our domain of x's is -1, 0, 1, 2, 3, 4. Our outputs of f of x, our range is 1, 2, 1, 2, 1, 2. So again, like I said, it's tempting to want to extrapolate that, but don't. So we're restricted to this domain. Okay, so I did not write that. I could write, what our domain is to be sure. So we have, is it a function? And this one, because each value has a distinct output, each input has a distinct output, we're good there. It is a function. I don't see anywhere on here where it fails. So yes, it's a function. Then we were looking for f of 1 is the first question. So if I have 1, that goes to 1 right here. So my answer is 1. F of 6. Since 6 is not in my domain, then that I'm going to write does not exist. So that's where I really probably should be writing my domain is all these values here. And I didn't write it as an interval because they're not continuous in between. It's just those distinct, discrete values. So then we have find f of x, and if equals 1. So I want to find what x is. So I'm going to look everywhere I see 1. Just here, here, here. Okay, remember I could have different x values going to the same output, but I can't have the reverse. So on this one, my x, and this is how you would write this, x equals -1, 1, and 3. Okay, you could put it in set notation like that also, but don't write it as an interval. And then f of 6, f of x equals 6. We do not have any 6's in the output, so we're going to simply write does not exist, or we could write no solution, something to that effect. Okay, so for the second table on to the right, we have a domain of 1, 4, -2, 1, 1/2, and 5. And we have our range is 0, 1, 2, 3, 4, 5. So let's take a look and see if it is a function first, because it doesn't really matter what all the other things are. If it's not a function, we're not going to be able to even talk about function stuff, right? So we just stop. So let's find one case is all it takes for it to fail. So I start by just looking at like what is the same in the x's, and do they go to the same y value or not. So I have a 1 here and a 1 here, and look, they go to different outputs. So then not a function. And that's it. Don't even do the rest, because the rest of it is non-applicable. Okay, you could write that if you want. Okay, so now we're going to look at question 3. Just note, sometimes your page numbers might not exactly match up with mine, just because I've used different formatting and rearranged things in a variety of ways. So just, I'm trying to match them up, but they might not always work that way. The graph below shows the mean flow rate R equals F of T for the Arkansas River in thousands of cubic feet of water per second as a function of time T in months since the start of the year. So first we want to find F of 7 and explain its meaning using everyday language. And we have B, F of T equals 2. Explain the meaning of your solution using everyday language. So one thing I want to point out first is that February is going to be here. We're going to have that as 1. So I know usually we think of February as the second month, but our starting point is going to be January. Okay, so January, beginning of January, no time has passed. Then we have February, then we have March, and so on and so forth. Okay, so does that make sense? And it's kind of right about here. So again, you can pause the video, shoot me an email. If you're not sure of something, I usually try to check email in the day when I'm not making videos, but I take breaks and I'll check it periodically. I have it turned off so it doesn't, for privacy as I make videos. So January, February, March, April, May, June, July, August, September, October, November, and then the last one is December. Okay, and that we will mark with as an 11. So now we're going to look at F of 7, and we're going to kind of judge it here. So 7 is the month of August. So we're going to draw a line up and see where that hits the graph. Okay, right about there. Then we have to travel over to the left and find our output. Now it's okay to estimate for these. It's not going to be perfect. So that's going to be about 1.7. So F of 7 equals 1.7. And what I would write for everyday language is on or around something like that, August 1st, the flow rate of the Arkansas River you can abbreviate, is about 1,700 cubic feet per second. Okay, so that would be my complete answer. For the next one, I want you to try that one on your own. Do be careful though, because we're looking at F of T equals 2. So we're finding the output and then where my inputs are. So draw a line across, or put a piece of paper or ruler or whatever you're using, and it hits at 2 points. Then just travel down and see how you interpret that. So go ahead and try that, and then I'll write the answer there and check back in a sec. Okay, so we have for an answer T equals 5.5 and 6.8 when F of T equals 2. So I just drew my line across and then looked down And we're just estimating approximately what it would be. It does not have to be perfect. Again, it's probably actually, if I look at my line, yeah, late July, it's pretty close to August, but the flow rate was 2,000 cubic feet per second in mid-June and late July. My dog saying hello to you all. Sorry about that. So when is flow at its greatest? And we can just look at the peak here. And travel down, and it will be about July 1st. So you can go ahead and jot that down. Okay, for part D, find the average rate of change of R from t equals 4 to t equals 6 and explain its meaning using everyday language. I'm going to make sure we have kind of around the same points, but again, it's an estimate. Also, keep in mind that you can put the speed of this video up to like 1.5 if that helps. I tend to go a little slower, so feel free to speed it up if you prefer. So we have AROC is going to be f of t sub 2 minus f of t sub 1. It's always a good idea to label things and write the formula that you're using. This one's pretty standard though. So then we have the AROC is going to be from, let's see, if I look at 6, my second one, I have that as about 2.2. And for 4, I have that as about 0.4. So we have 2.2 minus 0.4 over 6 minus 4 gives us 1.8 over 2. And let's condense that down to a unit rate, 0.9. And then write that in everyday language. So you give it a try. I'll write it out. Just pause the video and do it on your own. So the answer for this one is the flow rate increased about 900 cubic feet per second per month between early May to early July on average. So the key things to write are, about, and the months that you have there. So stating your interval that you're taking the average for, and then write that it's on average. Another thing I want to point out is as I was doing the problem, we're estimating all around. So I did change these symbols here to approximation symbols instead of equals. So that's the end of part 2 for 1.1. I'm going to make a new video for part 3. So have a great day.